Hello, guys. Hope you are doing well. Welcome to CFD College. I'm Ashkan, and this is the third tutorial of post processing in Paraview. Uh, in this uh, video, I'm going to show you how you can create some plots from every variable you want in Paraview in three-dimensional simulations. So before starting the video, if you haven't subscribed to the channel, please subscribe to this channel. Please share these videos with your friends so they and you don't miss the uh, future videos. And if you have any comments, please write down in the comment section. And also, if you have any questions, you can ask in the comments or you can email us. Here in the Paraview, let me import a three-dimensional simulation result. This is a three-dimensional simulation of a fluid flow in pipe with two diameters. So the pipe has an expansion. This is a three-dimensional domain, and we want to create, for example, a contour from velocity or pressure or any other variable. If you want to, plot a contour on the outer surface of the domain, this is an internal uh, domain flow inside the pipe. So the outside, the outer boundaries are walls. And if you want to show, for example, Y plus or wall shear stress on the walls, or even, the temperature of the wall, you don't need to do anything. You can just select the right variable because you are, looking at the walls already, and you don't need to do anything. But if you want to show the contour of this variable uh, inside of the domain, or if you have a external flow simulation, for example, flow over an airfoil, flow over a wing, flow over a wind turbine, you have to create some slices or isoclips in order to show the variable inside of the domain. So for example, if I want to see the midplane and the flow at that on that midplane in my pipe, so I have to create a slice or an isoclip. It's not difficult, it's so easy. We have some filters for this. If you see here, we have a slice filter. We will start with the slice filter. You can select it from here, or you can from this icon, or you can search it uh, in this in here. For example, you can search any filter that you want. If you write the name, you can see here, you can choose it. You can press enter. Let me press escape. You can find it here in the filter tab. Here it is, slice. So if you want to see uh, the flow inside of the domain, a three-dimensional domain, one way is to create a slice. So I choose my data, and then I click on this icon, a slice icon. You can see the properties. You can change the slice plane here. You can see it on the screen. So Uh, we usually use plain slice. We have other types, box, cylinder, or sphere, but the plain slices are the most common used. Here in plain parameters, by deselecting this, you can, you know, if it is checked, you can see the plane. And if you deselected it, you can only, you know, modify the relation of the the location of the slice through these settings. First, you have to, you know, specify the normal, the plane, the normal axis to the plane. The default value is here. You can see the default plane is normal to x-axis. In this simulation, I want to have a slice mm, normal to the plane, normal to the z. So I choose this. You can see the coordinates uh, have changed here. And this is the location. Here, if this is the plane at the middle of the domain, it's at z equal to 0. If you can change it if you want. You can see you can change it. You can, you know, rotate this plane, but the best way always is to use these coordinates. So 0, 0, 0. The x and y coordinates are not important. The only important parameter is z, because we are creating a plane slice. Uh, and the value range, I think we will talk about this value range in a couple minutes. And I think there is no important setting here. Yes, it's okay. So I click on apply to see the result, and I deselect this button. You see that we have a slice, a plane, a slice of the domain. This is the mid plane. If you want to see a representation of the 3D, you know, domain, you can uh, display it. And for example, you can change the color of the domain to solid color. And if you go down here, you can change the color, uh, and then you should decrease the opacity, for example 0.1. Now you see that you have a representation, you have a view of the three-dimensional domain, and you can see the uh, pressure contour on the mid plane. By clicking on a slice, you can change the variable, for example, to a velocity magnitude. You know that if you have seen our previous video on Paraview, you know that how we can change the presets, we can change the you know, data range, this color bar. For example, I choose rainbow, and you know, I don't want to modify the uh, contour bar again. You can refer to our previous video. So this is one way that you can see the uh, contour of any variable inside a three-dimensional domain. Let me hide this slice and choose the actual result. Now I want to show you some other capabilities. So I create a new slice, and this time I want to have a plain slice normal to x-axis. So this is good for us. The normal is okay, is correct, and the origin, the origin of the slice is placed at the middle of the domain, which is x equal to 0.3. So if you see now, this is the, for example, velocity magnitude contour uh, at cross section of this, at a cross sectional view of this pipe. Now, using this value range, we can add other slices parallel to this one, and this, which brings us a good view of what's happening inside the domain along the x direction. So I delete this one and I use this icon at a range of values. Uh, well, here uh, the x is 0, which is 0.3 meters behind this slice. Actually, so if we use the range of minus 0.3 up to 0.3, because here x is equal to, at the outlet I mean, x is equal to 0.6, which has a distance of 0.3 from this original plane that we created. So between these two, I want to add, for example, 8 slices, and you can see the x values of these slices. Let me increase it to have a nice values, and generate, and you can click on apply. Here, now you can see we have a good representation of velocity contour inside the domain at different sections in x direction. And this is, I think, this view is really useful for us. We can use it to talk about, for example, the uh, evolution of the flow inside the pipe. It's obvious that you can use the same method in if you have an external flow. You can change the color of background. You can change the color map, as I did in the previous video. This is good, I think. You can create really exciting contours using this feature. So it's how we can create some contours using a slice. But let me talk about a bit, talk about clip filter. Uh, uh, like the previous one, like a slice, you can search it, you can find it, or you can just apply it by clicking on this. And do not forget to select the main data and then apply the filter that you want. So, what is clip? Actually, clip, if you have worked with TechPlot or CFD Post or ANSYS Fluent, clip is an ISO clip. So in those software, we have a command named ISO clip. This is the same as clip in Paraview. So in this, using clip, we can uh, extract a value, a range of a value uh, let me show you. For example, if I want to have half of my domain uh, from, for example, the view of a symmetry plane, I should choose no, Z normal, and then if I click on apply, now you can see we have half of our domain from Z equal, for example, I think minus 0.02 up to 0 equal to 0, up to Z equal to 0. If you want to have the other half, you can just click on invert. Now we have other half of the domain, and you can use it to mm, show a contour of any variable on walls, as well as the inside of the domain. It's a good way, but more importantly, you can use these clips to along with slices. So if I add this slice, now you have, and let me choose uh, velocity magnitude for clip. Here we have a representation of uh, velocity contour inside domain and on different cross sections, which is a good representation for papers and also your reports. You can create some exciting and interesting, contours using slice and clip both together. Let me show you. Okay, we have one ISO clip for this side. So I add an ISO clip, another ISO clip for the other side. Okay, that's good. And let me hide and show the first one. Now, on this clip, I will create a slice, and like previous one, we choose 0, and we can add a range to have multiple cross sections. I think it's okay. You know how you can change it and apply. Now you can see here we have a contour of pressure at different cross sections, and on the other clip, which was the other half of our geometry, I create another slice. So if you noticed, I selected this clip and then I clicked on slice because I want this slice to act on this ISO clip. Like what we did, no, on x normal 0, and this is good. Let's add a range like previous one, and let me click on apply and change the variable to velocity magnitude. Now we have, and let me show the domain. Now we have both velocity magnitude. You can change it, the location, the position of two color bars, and also you can change the uh, preset to rainbow for both contours. Now you can see we have both pressure and velocity contours on different cross sections. You can create, I think, interesting results by combining clips and slices. This is just for you to see how we can combine these, filters to generate fantastic results, fantastic views of our results. But it's important for you to be creative and do, whatever you want using these filters. I think that's it. It's good for this session. Thank you for watching this video. Thank you for choosing us. Again, if you like the video, please press the like button and please share this video to your friends. Uh, until next video, uh, I should say goodbye to you. And once again, thanks for watching. Bye bye.